recording again. So we're back recording, and I'm sharing my screen here again, folks. And looks like most of us got this to work, and maybe using different techniques if you did the work on your own. And that, I hope those of you that did it differently than what I just did it, don't feel bad about it. It just, you thought differently about the problem, and you used a technique that was different than the one I borrowed from the author. So what I'm doing here is I'm borrowing the author's solution, and I hope I was pretty clear that there's more than one way to do it, and that's fine. It's perfectly acceptable. In fact, I typically, I know some people will follow verbatim what I'm doing. That's fine. Other people will do it on their own or try to do it on their own and then finish it maybe with the help of these videos or class sessions. We're going to move on to the next exercise here in just a moment. This one is exercise 14.2. And what I'm going to do is I'm going to get us started on this. We'll do a little bit of coding, and then we'll take a break because we're about at that point in the class, by the way. So for exercise 14.2, we're creating this tic-tac-toe board that says write a program that displays a tic-tac-toe board is shown in figure 14.43b. A cell may be X, O, or empty. What to display at each cell is randomly decided. So there, you got to use a random number generator. There's a little tip. The X's and O's are images in the files, same folder that we just grabbed, and they give you the name of those files so you can just pull them in. So some of the logic here, I think, should be pretty similar. One thing that we can probably decidedly agree upon right from the get-go is that a tic-tac-toe board seems to be in a grid. So a grid pane probably is a logical thing to use once again. So why don't we go ahead and get started on building this then. I'm going to come back to my source folder, right-click, and create a new class. Let's name this one exercise 14_2. Notice that for whatever reason it decided to put in a package statement here. I am removing it manually, and then I'm adding my public static void main. Click and finish, and we are all set. Next thing we're going to do is the standard stuff. We're going to get this stuff out of the way. We're going to extend application. Once again, control space at this spot to pull in the application class. That begets the need for the start method. So I'm hovering over the class title, then choosing add unimplemented methods. You see the start method. You guys also know I'm a big fan of moving this main method to the bottom. So let's just do that straight away. And then let's put the launch thing in here just so we know that it runs whenever we make it run. And then finally, I'm going to come back to that very first program that we had open tonight, where we have the scene, the stage, and all that. And I'm going to copy it into my new program because it will be needed. And that's good enough to start with. And I think now is a great time to take a break. So I'm going to just save my work here. Let's do a 5-minute break. It's 8:52. We'll come back at 8:57. All right, so one thing that we will notice that's very similar from this program and the previous one is the fact that a grid pane seems like a really good idea. And in fact, why don't we just go ahead and copy the grid pane structure that we have here. You know what, actually I'm not going to do that at all. In fact, what I'm going to do is I'm going to copy it from my other screen, and the reason I'm doing this is I just like what I named it better. So I'm actually copying this from my cheat sheet, believe it or not. And I'm going to just create these grid pane structures. Now I want you to notice like one thing that happens though as I'm copy pasting code in, I'm coming in from a different program where these libraries were present, right? You know, that we need. So you see right away, grid pane is underlining. So we got to go ahead and do the import here. So I'm hovering and choosing import. Also, the geometry positioning library also did not follow. So I also have to choose to import that one. That's one of the byproducts, unfortunately, of copy pasting code. Saves time one way, adds more time in a different way. I'm also going to bump these up to 10 pixels here. We used 8 last time, it looks like. Now, the other thing that I kind of want to return to is a discussion real quick about, why do we use image views? Why do we use image objects, etc.? And here's a really good answer for you guys. So the one reason we end up using, objects that get named, and in this case, I'm going to create image objects, by the way. And of course, this will require a library, control space. And this one wants to default to AWT, but I'm being careful to choose Java effects here. And as I do this, I'm going to name this image X, because I'm going to populate this object with the X that they indicated in the book. And it was named X. Well, we got to get the folder name in there first. X.gif. Additionally, we're going to do the same thing with the O image. We're going to say image O, and this is a capital O, not a 0, by the way. And once again, we'll say new image, following the same convention, and folder name first, and then O dot GIF. That's a lowercase o. Now, the reason it makes sense in this application in particular to use an image object, we have an image of X, an image of O, and the other possibility is no image. But when you play tic-tac-toe, it's likely that you will repeat X's and you will repeat O's. So having something that's named that you can just call back and use as many times as you want makes a whole lot of sense in this case. I would say that it didn't make as much sense in the previous application because we were using each flag once. In this case, we don't know. In fact, we're going to couple this all with some sort of random number generator. I do want you to notice where I put those images. I put them on the global level outside the start method. And in this case, that's probably not a smart idea. I don't really need them to be there because I don't need to access them from multiple parts of the program. So I'm actually going to move them and place them here inside the start method, just above the grid pane declaration. All right, now the other, probably most challenging part of this is populating the grid that we're going to form. Now, last time we had a grid that was 2 columns and 2 rows, and this time we're going to have 3 columns and 3 rows, and we're going to kind of add the contents in very much the same way. The trick really becomes, how do we do this whole random number part of it, right? Oh, I am noticing one underline here, this little red thing, where I have that old button thing here. We're calling our grid pane G pane. So I'm going to actually just copy that and paste it into the scene here. So that's the part that shows. There goes the error. So here below the grid pane, I'm now going to begin to do the logic for populating at random the X's and O's. Now, this might not initially dawn upon you for this exercise, by the way, but when you think about traversing a structure that has multiple columns and rows, and in fact, I'm going to do the annotation thing here again, where I'm going to kind of draw on the screen a little bit. We'll see how that works out, but I'll try. But if you can envision kind of like a grid forming that kind of looks like this. So there's 2 rows, there's 3 rows, and then we have, 3 columns. Standard tic-tac-toe board. And in fact, I should have drawn it like a tic-tac-toe board, right, where you don't put the edges on it. And if we were doing traditional coding and we were traversing a multi-dimensional structure, we typically would do that with a loop. If we were traversing one row, we would use a loop to traverse the row. If we are traversing multiple rows, then we would use a loop inside of a loop. And that's exactly what I'm going to do in my code so that I can step through these positions one at a time and then run a random number generator, generate a value, and then based on the value, put either an X, an O, or nothing in the box. That's the goal. All right, so having that little visual sometimes helps. So I'm just going to leave that off to the side, and then I'm just going to continue coding here. And I'm going to begin with a for loop. And I'm going to start this for loop, and I am going to put in a counter variable here. So we're going to start with I equals 0. And I'm going to run this. We have 3 rows, 3 columns. So from as long as I is less than 3, that should do the trick. And then we will increment I each time we run through the loop. And then I'm doing my curly brackets here. Now I've already got it in my mind that the way to traverse a multi-dimensional structure is a loop inside of a loop. So I may as well start building that second loop right away. I'm going to use, basically the same code here. The difference is going to be, in fact, I'm trying to do some efficiencies here. We're just going to change this, however, to a different counter variable. We're just going to call that J for the inner loop. And that's also going to run from J to 3, counting up to 3, but not including it. Remember, our rows and columns will start counting at 0. So we'll go 0, 1, 2, and done. We'll never reach 3, but that's still reaching 3 in principle. So now that I have that other curly bracket in place there, and everything's nested correctly, now I'm going to do the random number generation. So I'm going to create a variable called status. And then this piece of code you should just copy verbatim from me, folks. We want to generate a random integer. So that keyword like that is important. We're going to pull from the math random library. And then in order to generate up to 3 possible values, we multiply by 3 and then close the statement. So this combination here will generate 3 possible values, 0, 1, or 2. Those are the 3 possible values it will generate. Now, based upon those 3 values, that's where we will determine what the contents of our grid is. So we'll start by asking a question, then we'll say if status is equivalent to 0, one of the 3 possibilities, then we will do as follows. We will add to the gpane, so we'll say gpane.add, and we will generate, very similar to what the book is showing you, a new image view. So we're instantiating on the fly as needed, populated with image X. Okay, so if a 0 hits, they got an X. In the column and row index positions here, I'm going to let the inner and outer loop variables generate these for me. J, the inner one, will generate the column. I will generate the row. All right, and this will happen, and I want to get off of this so the box goes away, if a 0 is generated by the random number generator. Otherwise, let's do an else here. So we'll say else, oops, got to spell it right, else if status is equivalent to 1, then we will do exactly the same thing, but we will do it with O. And I am noticing my image view is flagging here, so we got to pull the library in, Java FX scene image. Let's take care of that right away. Then I'm going to copy the line. And I can basically use the exact same line. All I have to do is change this to the O, which is the same name we have up here. So still use the same index values. These are going to change automatically every time through the loop. And then for the third scenario where we would put in nothing, well, we don't have to do anything, right? So if it doesn't hit 0 and it doesn't hit 1, well, we don't have to add anything to the pane. We just leave it alone. We don't have to write a statement for it. There's no real third scenario. I guess you could create a blank image if you want and put it in there. I functionally don't see the purpose of that. That seems silly. All right. Now, believe it or not, this is all the code that makes this work, folks. So let's see if it works. So let's go ahead and do a save here. So here's my Control S, and let's hit that play button to get this going on the screen here. All right, so there's my output. And I didn't play with the size of the scene or the stage or anything. And I'm trying right now to actually click and drag this and move it, but it looks like I have to make it a little bigger first. But it did work. And did I actually call it my Java FX whatever? I sure did. All right, so maybe it's better to be called tic-tac-toe grid or whatever you want to call it. And you can make these bigger if you want, whatever. But clearly it worked. Now, my question is, how do we know it's truly random? So unfortunately, the only way to really know is to run it again. Okay, so it asked me to save. So there's another instance that just popped up. And did this instance generate a different grid? It sure did. In fact, let's keep running it. And notice that each time I run it, I'm trying to find a place to grab this. You got to make it a certain size before you can grab and move it, apparently. You can see that each time I run it, it does come up with something different on the screen. So it is truly random. Here's one actually, 3 in a row, tic-tac-toe, there you go. All right, so this is kind of like the types of output you might have. So I would recommend that when you do your screenshots for this one, by the way, that you show me a few different outputs so I can see that it's randomizing correctly. But folks, that's exercise 14.2. Everybody okay? All right, it seems like everybody's okay. I'm jumping over to exercise 3 now. And exercise 3 is write a program that displays 3 cards randomly from a deck of 52 as shown in 14.4.3. So this is, excuse me, what we're going to generate. And I'm sure you guys are probably already getting ideas about how you might accomplish this. They do tell us that, the image files, I think we've already looked at this, are named are stored in a separate directory in that image folder, so they're in the card directory, and that the cards themselves are named sequentially from 1 through 52, and they do this on purpose, right? So the part of the file name is a number, which makes each file unique, but also because it's a number, it allows us to do numerical things to our programs to generate values to be able to work with the cards and be able to pull them in randomly. And so this is kind of a weird little thing. There's also this new tool that we didn't quite get a chance to learn about so much when we were in Java 1. You run out of time basically. But we're going to be pulling stuff from this structure called an array list, which is super, super similar to an array, has slightly different syntax, but basically works the same way. And this is going to be kind of a fun little exercise, I think, in terms of some of the new things you guys will learn in the process of doing this. So let's do the mechanical pieces first. Let's start building the program and get our infrastructure in place. And so you'll see, like, as you're building these programs, folks, that this is kind of like what happens is you get kind of into this flow if you're doing it over and over again. First thing I'll do is exercise 14_3, which we talked about. I'm going to clear the package declaration, add the public static void main, and go ahead and say finish. So this is exercise 14.3. We're going to do all the things that we've been doing. So we're going to say extends application, and then we're going to control space to get the library in place. Then we're going to hover and add the start method. We're going to move our main method to the bottom, my preference. Add our little launch directive here, launch.args. I'm going to delete this unnecessary comment here and then do a control S to save. Now, I'm thinking about this one a little bit differently because there's a few things that we have to do. And when I think first about the visual aspects, well, one thing I know for sure is that we're going to need our stage and our scene and all that. So I'm going to come back to my previous program and grab the scene and the stage declarations. And I'm going to put those right here at the bottom of my start method. Just pasting those in. I'm not sure what I'm going to call it yet. Will I use a grid pane? Well, I'm going to tell you what, looking at that graphic, I'm going to say I don't need a grid pane. In fact, these are all on a horizontal plane. I can use a pane structure known as Hbox to do this. So that's what I'm going to do. So I'm going to begin by creating that structure, and I'm just going to make it right here above the scene and the stage. And I'm just going to say Hbox, capital H, capital B, by the way. And then control space. Let's get that library in there immediately. And you can call it, whatever you want. So I'm just going to call it, I don't know, how about HB1 for Hbox 1. And then we need to instantiate. So let's go ahead and do that process. And then, you might leave the parens blank here, but you can put in horizontal spacing here, by the way. So let's go with that 10 pixel amount that we've been using. And so all the cards that come on the screen will have 10 pixels of visual space in between them. All right. So now that we have the Hbox, I'm just kind of giving you a fair warning here. I think a really good thing to do whenever you're putting visual elements on the screen is always to set alignments so they look nice. And I'm trying to invoke the automatic tools here, so you see me kind of backtracking just so I can invoke it. And then we'll once again do our position dot center. I'm using the arrow keys and pressing enter to do all the library additions automatically. All right, so that's the Hbox. Now we will at some point need to put images into the Hbox. So why don't we kind of build the preliminary mechanics for that? And then we'll repeat it when we get to that point. So the first thing that we're going to do is we're going to look at the name of our Hbox, which is HB1. Oh, and that reminds me, we should probably put that here in the scene, right? Because that's what we're going to ultimately show the world. And then for HB1 here, we are going to add objects to the screen. However, because there's going to be more than one object added to the Hbox, instead of going directly to the add command, I'm actually going to say this command, get children, which means there's going to be multiple things to bring in, followed by the add command, and then all the parameters that I want to throw at it. So like whatever I'm going to throw into that Hbox is going to go here. And as you can imagine, it's probably not a bad idea to put like an image view or an image object in here to put it on the screen. And then I'm going to end up repeating this process several times. In fact, I'm just going to copy this line as is, and we're going to put 3 cards on the screen. I'm just going to paste it 3 times, and we'll do each card added separately. These will be replaced by the code that we need to make that happen, which I will generate as we get to that point. But it's going to be something to the effect of this. In fact, I can get the preliminary part of it built now. So I would, in most circumstances, instantiate on the fly new image view. Okay, so first question you might have is, Ty, why would I instantiate on the fly? Why wouldn't I just create this and name it and then call it in? Yes, you can do that. The reason why you might not, right, is with this program, this image is going to appear once. We're not reusing the object, so there's no reason to go ahead and pre-name it just to take up memory space. We're just doing it brute force on the fly. So it's called on the fly instantiation, by the way. Then normally inside the image view, this is where we would say like our image slash card slash whatever the card is. And if you remember from that thing that they had in the exercise description, all the cards are named like 1.png, which is probably like the ace of diamonds or something. And then they're named numerically. So really, ultimately, this number is going to be changed in our code to dynamically pull in a random card. That's how we're going to accomplish it. And for right now, I'm just going to leave it hard-coded like this so you can kind of see where we're going with it. I am also noticing image view is underlined, so I'm going to do the import here of for JavaFX. So that adds a library for that. All right, so now we're going to talk a little bit about this whole array list thing that they're talking about and this cryptic shuffling command that they're also kind of alluding to. And this is not code that you would accidentally find in the book, by the way. In fact, assuming that you had instruction on array lists, that helps. It also helps to know that they actually have utility functions that shuffle the contents of arrays. Now, interestingly, why do we do this with an array list and not a regular array? Because the shuffle command is automatic on an array list, but not automatic on an array. So that's the why. All right, so let's go ahead and create an array list. So now you're learning about a new data structure, as well as how to shuffle, we're going to create an array list object, and you can see right away that's also underlining, and I'm going to go ahead and yes, pull that in from the Java utility library. Now inside, you notice I'm using here not square brackets or curly brackets. I'm using brackets like we do in HTML, which are the greater than, less than symbol. And when you create an array lists function very much like arrays. However, they are forced to be of a specific data type. And in this case, we are going to populate it with integer, but not int lowercase. Notice uppercase, which is a class, and it's a separate type of capability for integers. This array list we will refer to in very similar fashions to how we refer to a regular array, but we will be using typically parentheses to access the list items as opposed to square brackets. One of the functional differences. The array list needs to be named, and I'm just going to call it list, or you could call it cards, I guess, whatever works for you. And then I am going to instantiate a new array list. It does have a constructor function, and watch for the funky bracket, then followed by parentheses. That's how they do it. And then basically what we've created is a structure like an array that can hold integers that have the capability of interacting with the integer class. And because it's an array list, can also be shuffled with one command. And that's why we use it. Now, we've created this list. This is just an empty array list. It has no size yet. We didn't say it should have 100 positions in it or anything like that. We just created it as an empty spot in memory capable of holding integer class objects. Now we are going to populate that array, and we already know in advance we're putting integers in here. Why are we using integers? Because the image card library, all the cards are named, at least before the dot in the file name, with an integer from 1 through 52. That's the why. So I am then going to populate this array with a for loop as my friend here. I'm going to create a counter object here again. So we're going to start counting. Actually, we're going to start counting at 1 for this because there's no cards that are named 0. See, right? So we're going to start counting at 1, and we're going to let I go from I as long as it's less than or equal to 52. And once it reaches 52, it's done. And then we will increment once each time through the loop. What are we doing in that loop? Very simple. We are going to take whatever the value of I is, we'll start at 1, and put it in each list position. We do that by calling the list that we're adding to, and then saying add. And what are we adding? Well, our counter variable for the loop. It's going to automatically increment up to 52. And so if you can conceive of this, we're creating an array list with each position populated sequentially with the numbers 1 through 52. Each one of those numbers then symbolically represents one of the cards in the deck. All right, so we've populated the array. We've created an array list of integers, and now we've populated that whole array with the numbers 1 through 52. Then we call upon the magic command. And we'll do this by calling it right from the master libraries. We're going to say Java Util, even though that's probably, well, it's not imported up there, but I suppose we could do that. And then we're going to pull in this tool for collections, which array lists fall into, by the way. And then we're going to call a method called shuffle. And what are we going to shuffle? It intuitively said, hey, you have a list here that'll work. All right, let's use that. And so we're going to just say Java Util collections shuffle. And what that does, as you might guess, is it takes all the numbers in the array lists and mixes them up. It randomizes all the contents of that array is what it's doing. And once again, the reason we're doing it to an array list is because we can do it to an array list. It's much more difficult to do it to a regular array because of the way the structure of the data is underneath. Array list is made to do that in combination with the integer class. All right, so now that we've done that, here's the fun part. When we are going to be pulling in these cards, so you guys probably thought maybe the way to solve this is I'll put all the cards in the array. Maybe you figured out the number thing. And then I will randomly generate 3 numbers and pick from that list of 1 through 52 and pull that number back. What the author did much more intelligently is that makes for complicated code. Why don't we just shuffle the array content, since we can do that, and then just take the first 3 positions, because those will be random, right? That's just like if you played cards with somebody, you'd shuffle, you'd cut the deck, and then you'd deal the first 3 cards, and whatever you get, and that's what we're going to do here. The thing is, how do we change these statements to match up with those first positions? And here's how we're going to do it. First of all, we're going to replace that position right there with a command that pulls the value out of the array. But we still need the text to point to the file, so we're going to kind of concatenate to it these pieces here. And you can see how Eclipse is trying to like kind of complete the blanks here for me. But we're going to start the path name, concatenate to it whatever we pull out of the array, and then concatenate the end of the file name to it. And that's how we're going to trick it into doing it. The command is pretty simple. So if you can kind of almost even extrapolate that if there's a command to add stuff to a list with the position number, there must be a way to get stuff from the list, and that's the actual command. So you just say list.get parens and the index value. And for the first one, we're taking the first position, still referred to as position 0, and we'll grab whatever card is there. Then we're going to do the same darn thing for the remaining positions, the remaining 2 positions, the first 3 positions, basically. And really the point of this, is to simulate what you would really do with a deck of cards, because that's what you would do with a deck of cards. You take it, you would shuffle it, reorder it, and then face down you would deal, the top ones to the person, and that's what they get. So we're going to take position 0, we're going to take position 1, and we're going to take position 2, the first 3. And folks, that should do it. This should be the whole program here, with any luck, unless I made a mistake somewhere, and I don't think I did. Here's our code. So I'll let you guys just take a moment and look at that, compare to your own. And I'm going to go ahead and do my Control S to save. And here I go hitting the run button. And if it worked, we have 3 cards. Yeah, we have to change the output size here. So we need to go wider. So let's make this, I don't know, 400 wide. Control S to save. Let's run it again. And why am I running it again? Well, I want to make sure it's random. That's once again, here's my first run. And see, I'm still calling it tic-tac-toe grid, so I got to fix that too. And maybe we should call this 3 random cards. Let's save it, run it one more time. Let's prove it's truly random. Then we can look at the last 3 iterations here and see that we indeed are getting different cards each time. In fact, none of the cards repeated, which is a really good sign. So every time I'm running the program, populates that list automatically, shuffles it, grabs the first 3 numbers out of the array list, and then uses that to complete the path statement to pull the file in dynamically. And I think that's a pretty clever approach, a very efficient one, by the way. And we were able to accomplish it with a minimal of code. We're moving on to exercise 14.7, and this one reads as follows. Write a program that displays a 10 by 10 square matrix as shown in figure 14.4.5a, so just below here. Each element in the matrix is 0 or 1, randomly generated again, and each number centered in a text field. Use the text field set text method to set the value 0 or 1 as a string. And so we'll go through all of this in pieces. But the beautiful thing about this is I'm hoping that you're starting to see patterns are forming in terms of how we're doing visual output. And that's not by mistake, by the way. I try to get a smattering of a few of these. So the first thing I hope that you recognize immediately is, wait, we've already done multi-dimensional structures. I bet you we're going to use a loop within a loop. And you're right. to traverse that structure and populate it. The other thing that we're going to do is we're probably going to use a grid pane because that makes sense. That's the other thing for that. It's a logical structure to go into. And then we got the whole random number thing, which I think we kind of have figured out at this point as well. And so a lot of the pieces really are already in place. It's just changing to different tools and how fastly can we ramp up to that. All right, so coming back over to Eclipse then, let's go ahead and begin by creating a new class file here in our source folder. And this is exercise 14.7. And once again, I'm clearing the package declaration on this, folks. And
you need to share.
Oh, thank you. And right now, we had just beautiful time of me recording my face, which I hate doing in these videos, but here you go, folks. All right, but we got to the point where we've generated this brand new program here, and Ken, thank you for saying that I wasn't sharing. Thank you. All right, let's go ahead and do all the standard stuff here. So we're going to extend the application, see how fast we can do it. You do get into a workflow with this, believe it or not, especially when you do one right after the other. We're going to add the start method. We're going to add the launch args. And I'm going to move that to the bottom. And then we're going to get rid of these comments here. Once again, we're going to grab the stage and the scene. I'm actually going to go back a couple on this one. I'm going to grab this stage and scene. And then I'm pretty sure we're going to use a grid pane. So why don't we just go ahead and just start building that? So right here, I'm just going to say grid pane. And you can call it whatever you want. I guess I'm just going to call mine pane for now. And say new grid pane. And I'm not throwing any parameters at it here. All right. We need a library for grid pane, so let's hover. Import grid pane JavaFX. And I suppose the name I have down here in the scene should match up, so let's get rid of that letter G so it matches up. And let's make this a little bit larger because I get the impression the size we've been using lately isn't going to work. So let's maybe go like 500 by 500. Just do that preemptively. And let's also change the title since we're trying to be right about this. Exercise 14.7. That's good enough. Right, saving.
Can I ask a question real quick, Ty?
Absolutely.
So on line 17, where we have our pane that's being like initialized and everything, what happens if we leave out the 500 by 500? Does it just auto size or does it throw errors?
No, it will auto size to whatever the size of the object is. And I forget exactly how you drive it. So like if you don't declare a size for the object you're putting in, then it does pick some sort of default size. I can't tell you what that is. If the object is size, so let's say like I gave this grid pane, a global parameter of like 500 by 500, I could functionally eliminate this. But it's all about that encapsulation of control. Most programmers will either launch their stuff full screen or to a specific size, or otherwise I think it goes to system default. And I think for Windows, it's probably something that's like 1/3 the size of the screen. I think it's pretty typical, half to a third, something like that. But good question. Absolutely.
Yeah,
In
thank
fact,
you.
One thing that some people will do, and this is kind of actually a great time to drop it in some cases, they populate these spots with variables or constants. So here's an example, and I'm just doing this for sake of example to follow your question. I could set up constants to control these things here. So I could, for example, and yeah, inside the start method is where I want to do this. I would maybe set up like I think those numbers are doubles technically, maybe like a width of like 300 and a height of, I don't know, 350. You choose whatever numbers you want, and then those values would populate, the size. And sometimes, in some situations, you calculate these values and populate them through variables. In other situations, They're hard coded, and it's all kind of dependent on what you're doing. We're frankly doing pretty simple stuff though, so it works out, pretty nice. Now moving on to like the other part. Now we know we're going to traverse this. Was it 10 by 10? I think structure. Um, that's two-dimensional. So there's rows and columns once again, and we know that a for loop inside of a for loop works really well for that. In fact, I kind of have one built here already. So I'm going to grab the first two lines. So why like reinvent the wheel, right? Let's drop this in and tweak it to what we need it to be to make it work for our situation. I'm going to use the same counter variables. I'm going to use I and j. I do know that I'm going to have 10 rows and columns, so I'm going to change these numbers to 10. That should work just fine. And we're never reaching 10. Remember, counting from 0 to 9 functionally. Now, in terms of how we're going to put the actual content inside of these, well, that's a whole separate scenario. In fact, I'm going to make sure that my curly brackets are closed here, so I have both my loops closed. But now I got to think about this a little bit, because we did get this clue from the book that we should also use text fields to get these little boxes, so they're not just numbers just jumping onto the screen. Any text you put on the screen has got to be put into some sort of an object that can contain text. That's really what it's about. So that's what we're going to do here is inside the loop. So every time we iterate this multiple loop structure, we are going to generate a new text field every time. So every time it goes across all the rows and down all the columns, it will create a new text field for each one of those spots. I'm just going to call it TF, text field. And we will instantiate a brand new text field. Boy, I'm just like mistyping like crazy here. And then throw some parameters in out. Normally, when we generate a text field, we have certain parameters that we can throw in. First, I'm noticing, hey, wait a second, this is underlining red. Let's control space our way into the right library here. Just make sure you choose JavaFX and not AWT. And then normally here, we might actually do something like put in text, or more importantly, add information that we might need in the screen. If you remember that the problem description said we want to put a 0 or a 1 in, and that is text, right? Could I randomly generate it right here in that position, right between these parentheses? And the answer to that is absolutely yes, you can totally do that. So let's go back and borrow from wherever we had a random number generator here. It's funny how quickly we forget where we did that. I think we did it in every program, right? Was that the
It was
problem?
in 14.2, I think.
14.2, thank you. Oh yeah, right here. So the way that we generated this integer, for example, and I don't need to generate it as a variable or an object, but this little tidbit here will certainly be useful. So I'm going to grab that whole bunch of code there. I'm going to bring that back over to 14.7, and I'm going to drop it right inside the parentheses. And will this generate a random integer? Yes, but it's going to generate 0, 1, or 2, but we want it to be 0 or 1. And that's kind of a little bit odd, because what number do you put in here to generate that? And you might do a little bit of research on it, but I'm going to save you a little bit of time. And the number you put here to make it generate 0 or 1, by the way, is 0.5 for whatever reason. I can't say I remember what the rationale is behind that, but there is a rationale behind it. The other thing that I'm going to do is, you see me adding an addition sign here. It's actually a concatenation symbol. Is I'm adding an empty string to the end of this, because this will generate a number. Unfortunately, numbers cannot go into text fields. So I'm concatenating to it an empty string, which then takes that number and basically turns it into a string. All right. The other thing that I'm going to do is I'm going to add a couple of things here to allow what we just generated to appear on the screen. And ultimately, the main command is to add it to the pane. So I'm just going to say pane.add, and then what are we adding? Whatever text field we have, followed by our column and row index. And the way that we did this in the other program was J was the column and I was the row. And those are automatically generated as it goes through the loop. The text field is generated dynamically. Every time we go through the loop, it generates a new text field and randomly puts in 0 or 1. So this would actually get the information in there. There's a couple little tidbits that we add to this to just basically make it look better. So I'm just going to copy paste these in for you. And it's these two commands. So the second one we've already seen. And in fact, let's hover and make sure we add the Java effects geometry library. And then let's talk about this first one. So this one just takes the contents and centers them in the text field. So it just looks better. And that's a preference thing. The other one is this preferred column count. And this is very similar to how we work with text boxes in HTML, by the way, where you specify really what we're saying is how many characters are available inside this text box. And I think that the default, I think it defaults like 8 or 10 or 12 or something like that in size, which is not going to give us that grid that we're looking for. We want it to just hold one number, so it creates this tiny little text box. And so we're saying the preferred column count to 1 to accommodate for that. That is shown in the readings and stuff, but that might be something you miss also. So that's why I like to point it out. Believe it or not, program is done, folks. This is all of it right here. This should make it work. Let's see if it actually does. I'm kind of leaving the code on the screen here for just a second. Make sure you guys are catching all the important stuff. And then I'm gonna hit the Control S to save and hit the run button here. Let's see if it works. And there it is. However, what is not working?
Not getting any ones.
Not getting any ones. So I'm going to tell you what, 0.5 is incorrect, right? And so wherever I'm copying this from, apparently from myself, that's not the right value to put in there. If we want to just get 0 and 1, what did we put in last time to get 0, 1, or 2? Put in 3, right? So would it make sense to put what here?
2.
Yeah, all right. So I'm surprised nobody spoke up earlier and said that. Yeah, let's try 2. Save, Control S, and let's hit the run button again. Aha, much better. Okay. Is it random? Let's run it again, and then we'll just compare. And you'll notice that when you do multiple iterations, did these come out to be different values? I'm just looking at a few random spots on the screen, and yes, they are different. But you notice we were successful here in getting this completed. All right, well, that completes exercise 14.7. Unfortunately, we cannot get to 14.8 tonight. We just run out of time. I did give some tips, though, to everybody that it's really a combination of some of the techniques that we've already used. And the exercise basically gets you to display the entire deck of cards. And probably the hardest part of it is deciding how big to make your rows and columns. And you basically control that through the 2 for loops that you would use for columns. And if you have 54 cards, you can, what numbers go evenly into 54? Well, hint, what's 9 times 6? Start there, and then you'll be most of the way there for getting that one done. All right, folks, I'll see you all next time. And this recording ends here.